Hello. Yeah. Hi there. It's 9:30, so we should start the very first session in IETF 100. So this is the ANIMA working group meeting in Singapore. So if you are happy in the wrong room, still have the time to find the right one for you. This session will be 2.5 hours till 12 o'clock. This is a notebook. Everybody should know it. If you haven't read it carefully, please do. The blue sheets already passed around, so make sure you sign it if you have to do before the end of the session. And we did job scriber. Anyone here? Okay, thank you, Terence. We did minutes taker. Any volunteer for minutes taker?
You get 100 IETF brownie points for it.
Bing, could you do this? Thank you. We also have the remote participant. There are 2 at this moment. All those slides has been uploaded in advance, only yesterday. But that's available for everybody and for remote participants. The mailing list, as usual, is one of the main working place in IETF. So the discussion will be continued in mailing list, and all those working group decisions made in this room will be confirmed in mailing list. The chair is myself, Xin, and Terence Erikin. So we also have the website for data tracker. This is an update for you for the working group milestones. We actually have 7 working group documents. GRASP already in the RFC edit queue. There are 2 misref, one for ACP, one for Copper. Yeah. And as long as the ISG receives the misref, they will be published. The voucher has passed the working group last call in June. It's submitted to ISG for publication as standard track in August, and now it's with ISG. The prefix management document also passed the working group last call in July, just after last IETF meeting, and it's submitted for publication as informational document in August. It's in ISG with ISG now as well. And the stable connectivity as another one of 2 validation use cases passed the working group last call in August, submit to ISG for publication as informational document in October. So it's waiting for AD evaluation. And we still have 3 documents with the working group. The autonomic control plan passed the working group last call. I only made the result yesterday, but actually that's 2-week working group last call period plus 2-week extension. So that's waiting for another round of author update and Sheffield writing up. I will submit it to ISG for publication if there's no significant change for which request the second working group last call. And Brisky tells us the Sheffield already done 1 round of review, but it haven't been followed very well, so it has to do it another round again. So we are planning to have working group last call in next month and submit it to ISD before, in January probably. And the reference model, I haven't done a Shepherd review yet, but we'll do it soon. And plan to have working group last call in December if there's no significant issue after my review. Okay, that's the 3 documents with the working group. So we actually have those 3 working group document update presentation this morning at the very beginning. So for each of them. And then we have the 6 new work items, new proposed work. Some of them already discussed in the working group since we are keeping the second session for most of meetings. So some of them already have been discussed well. And the chairs believe at least 2 or 3 of them are actually in the current charter, which means we may be able to add the milestone without modify the current charter. And the others we may need to discuss that with our AD afterwards to see how much they are relevant to the current charter and how much they may have to change the charter, or even they are out of scope. So that's what we'll be doing afterwards. So there's GRASP API, sorry, and the informational distribution over GRASP, and the guidance for autonomic service agent, also the bucket data over GRASP, and towards public PubSub and storage integrating in animal concepts, and DNS SD over a GRASP. So that's 6 presentation we had today for the non-chartered work item. Each of them have 15 minutes, but I have asked the presenters to keep their presentation shorter, but given the ideas why this work is important and how they fit into the working ANIMA working group charter, and hopefully leave enough discussion for the working group to say whether those proposed work are interested by the group or not. Any agenda bash? Okay.
So can you go to the uploaded slides? There is a slide from Michael that should see.
Okay. So next, you want me to download this one? No, you can use your laptop. You can use your laptop. Yes. I need to do this. Yeah. I did set up. Sorry for the mess. Actually, the first presenter only just updates the slides, so I have to re-download it. Not actually Mike Richardson. Yeah. So Brasky, which one? This one? Yeah. Okay. Okay, so you'll give it. Are you?
Okay, Michael, you're up.
Hi, can you hear me? Yep. Good, wonderful. A little bit echo, but all right. Since June, since the last IETF, just prior to that one, we did a reorganization of the document, and a lot of the document was of our previous text and organization was moved into an appendix, and we kind of redid it from a somewhat different organization. This was based upon feedback from a number of implementers that they wanted to have a more clear walkthrough kind of point of view. Since then, we've been working on essentially clarifying the text, making it a little bit better. We fixed the proxy discovery registration that originally had been conceived of as a typical GRASP discovery. It's now an M-flood from the registrar to the proxies. We went through a bunch of discussion of what the domain ID was, and at one point we decided it was going to be the registrar ID, and then we went back to domain ID. And this is maybe just a choice of term, but it has to do with whether or not the domain is identified by the last public key certificate in the chain or by the self-signed anchor point. And then that leads to the question of how the domain itself owner is pinned in a voucher. Particularly in light that some would desire to use a web PKI, which is not self-signed private PKI, but rather descends from something like GoDaddy or VeriSign. So clearly the domain owner is not VeriSign. And if you were to pin the top cert, which is what we said to do, then that would be wrong. So we're pretty sure that we want to pin a set of certs and not a, say, VeriSign plus a DN. We want to pin a specific thing. But current tooling either says send the entire chain or send just the last piece, or, you know, it doesn't really let you do what you want. So we think that's really a tooling issue, not a text issue. But we really want to just pin the domain owner. It's really easy if it's a private PKI and it's self-signed, the domain owners who they say are. It's only when somebody wants to use something that's anchored into some public PKI that there becomes an issue. We added there'll be some sample example vouchers, including private keys and voucher requests in the next revision, which I think that Max and I will be posting today. Next slide, please. Can't read your side. Oh, we ripped out all the Appendix D. So we think that between revision 6 and revision 9 that we managed to essentially find all the text that we thought might be still valuable. We merged it back in, and finally we ripped out that collection of text that we had been accumulating and kept around for a while. We changed the definitions of proximity registrar cert and prior signed voucher request. At one point, these were kind of overloaded between whether or not it was a voucher request versus a voucher. So proximity registrar cert is always the pinned name of the domain ID, and prior signed voucher request can contain a prior signed voucher or request. And that's actually how the pledges signed or unsigned voucher request is passed by the registrar to the MASA. So there's some good text in there to explain how that works and why it happens. And I think we're pretty happy with that at this point. We put a lot of text into a number of sections to even them out a little bit. We moved some things out of one section. The proxy got its own section again, which is a little bit of a regress to how the previous organization was. But the proxy is kind of a separate thing. It doesn't really participate in a semantically meaningful way with the rest of the transaction, but yet it does exist. Next slide, please. We went through a bunch of cycles and iterations with Diana registration details. This is back and forth with the voucher document as well as to what exactly we were going to call things. So we believed at one point that we were going to be registering our own MIME type, and we had some template text out to register that. And in the end, we're not going to do that, as point 10 says. We're actually going to be an application PKCS MIME. And then we would have a new SMIME type voucher or voucher request. But just to be clear, it may be that it's really going to be application CMS. So the voucher document has really moved in that direction, and we're going to fix that as soon as we're absolutely sure that the voucher text has passed all the reviews and everyone's happy with that. We considered what to do if it's HTTP2, particularly because HTTP allows you to have concurrent requests, and our state machine very much says you have non-concurrent requests. You have to do A and then B and then C. And so it would be bad if somehow we started doing C before A was finished. So that's really about building your client correctly. And it shouldn't be a problem, but I can imagine somebody that got their client to work correctly with HTTP 1.1 sequentially and then breaks with HTTP 2. So in the end, we decided there wasn't really a lot to say about this. This is someone's implementation issue. But we did tighten the requirements and make it pretty clear that we are expecting HTTP 1.1 persistent connection, and that if you have to renegotiate the connection, the TLS connection, then you've got some problems that are going to happen. That's really it. That's the update.
Thank you, Michael. So may I ask you, as your open? Oh, hello. Darius, may I ask you your opinion as the working group, as a document shipper? How do you think this document ready for working group ASCO or when?
I think I would like to do my second Shepherd review round and then basically come to that conclusion, right? Unless I stumble across, unexpected gaps or so. I would hope it is, and so I hope we can make close out on this document soon.
Yeah, I think we're ready. I think we're really ready for last call, and it would be good to have another review from you, and but also from some people that perhaps have never read it before. See if we missed something or confused you. That would be very good to use.
Yeah, and in warning, with my experience with the authors on the first round, so they have a great system of driving changes to the document through Git, and so instead of only sending to the mailing list, which obviously is an IETF requirement, it's always good for this draft to bring up considerations as issues on the Git itself.
But you can also send it to the mailing list as well. But it's good.
You always must send it to the mailing list, right? But given how long the mailing list is, the issues are actually a very nice way to track individual points.
At present, we believe that we've closed all of our GitHub issues. There's one that we're just using to track something else, but it's pretty much we've been meticulous about closing them all. So thank you.
Yeah, go ahead. Right. No, there are power button on it. Yeah.
Someone coming to the mic.
Yeah, just because I'm watching the Jabber, Bill Atwood said he is in the process of reviewing Brewski, I think for the first time. So you've got at least one person looking at it.
All right, thank you. So, actually, Terry, you're on Phoenix.
All right, so just wanted to give a quick update on the changes since Prague. As Sheng mentioned, the document is past working group last call. So this is just for information purposes. So there was thorough reviews by Brian, Sheng, Michael, and some smaller points from others. So thanks a lot for that. We had the discussion of these points and feedback to the mailing list. And so I think Sheng is going to do the final Shepherd write-up. So this is primarily, for the history books, just the summary of things. A lot of details. I think we want to spend more time on the new stuff. Let me see which of these particular elements are of interest. Well, the one thing, people were starting to ask, like Brian, about virtualization. And so we had all these wonderful, inconsistent terminology, device, host, physical, and so on. And so I tried to fix up the whole terminology that everything is a node, so that it's more logical, that it could be a virtual router, a VRF function as well. And then instead of physical interface, I use the term native interface because I really don't know what a physical interface in a virtual machine is, but that is novel in the IETF, so I don't think we have defined terminology for that. We're keeping the term loopback interface. There has been discussions. The IETF doesn't have a better term to phrase that, but so yeah. So there was a lot of good, I think, clearing up of terminology. Next slide. So right. So basically, the ACP now demands that all nodes must support certificate renewal through the ACP via EST, which is distinct from Brewski. So when we started this out a couple of years back, most folks working on the ACP were thinking Brewski was the document that was specifying that also. Basically now Brewski is really only the bootstrap part, and the certificate renewal is simply standard EST, so we clearly separated that out. And also announcing that through a separate objective in GRASP from Brewski, so that it could potentially also go into, you know, other systems on the ACP. Next slide. So yeah, there was a big bug in terms of thinking we could use a transport mode with IPsec. Obviously, we need to use tunnel mode with IPsec, so we stumbled over that. Because obviously the ACP is forwarding packets, so that it's not only all locally generated packets. Then I did add a lot of text about the GRASP, specifically also in the section of why we're using GRASP for service discovery and what we consider that to be, you know, a basic property of the ACP, that it supports service discovery with GRASP as opposed to IP multicast, which is what I've seen a lot of communities always coming back to. You know, prior life, I've been doing a lot of multicast, and then people say, oh, let's do that for service discovery, and it's really horrible. So yeah, you can read up on that, and there are also a bunch of, you know, optimization in the future we can do with Ripple. Next slide. So this was basically the you know, magic outcome after the GRASP security review, where the security ADs were asking, okay, what's the security of GRASP itself? And it basically, when we finalized GRASP, we said the security isn't in GRASP itself, but it's in the underlying transport security substrate. In our case, it's the ACP. So this is basically the picture showing how we're forwarding in the ACP packets between different secure channels, once as datagrams over, for example, IPsec, for just the forwarded, just to provide the IPv6 VRF that the ACP is. And then in addition to that, we're basically for GRASP itself, building end-to-end TLS connections. And that is because in the security review, the question was brought up, what happens if we have impacted nodes in the ACP that cannot be trusted anymore, and you're just, you know, passing unencrypted GRASP messages through it? Well, the outcome would have been that if we would have kept this, which is what we started out, then the security folks would later come back and tell any ASA that we're building that if you're relying on GRASP, you still need to come up with an application layer encryption because you can't trust the intermediate path all that much, right? That's basically why I said, well, let's cut this short here. Let's move to TLS also for the unicast in the ACP for GRASP. And so that's the picture showing how that all interacts. Next slide. Ripple routing, yeah, a bunch of details of other things. So in the whole IP and IP encapsulation scheme, the need for more addresses came up, and initially we had an addressing scheme in the ACP that would give every ACP node up to 8-bit worth of addresses. I changed that with a bit so that the addressing can now assign 8 or 16 bits to every individual node. And the other things, Ripple, yeah, worked a lot with the Michael and Pascal on figuring out all the details for Ripple implementation. Next slide. Yeah, so then all the ACP interfaces, right? So in terms of, you have secure channels, you have an IPsec channel, okay, how you're running IP over it, and especially if you have a LAN, you have multiple ACP neighbors and you want to make it look like a LAN. So I was looking on a bunch of IETF mailing lists. There isn't really good reference, so I basically chunked up a section explaining how you'd basically create a virtual LAN interface on top of multiple point-to-point ACP secure channels, run ND on it, So hopefully that's sufficiently complete to allow implementations. ACP Connect was also extended, the section, just to showing that, what many people have started to see as a workaround, like you connect a non-ACP device to the ACP, is actually a very good long-term option if you're really thinking about composing software in a device through multiple software modules that you connect through, internal virtual interfaces. Because at that point in time, you don't need inside a system to run, another crypto layer, right? So next slide. So then I added a section about diagnostics, which is usually, I was funny talking to other folks in the IETF about their solution. They said, oh, we forgot about diagnostics. I need to do it now. So these are all informational pieces. Also, the whole discussions, which I think had been going on for a while, but we never had good text for it, right? So how do we enable and disable the ACP globally on a node, on a per interface basis, right? So we just started out with a simple example. Well, you don't want to do ACP discovery on an ACP secure channel, obviously. That's clear. But basically now there are all these details about brownfield, greenfield rollout, and the global and interface enabling and disabling. Next slide. Okay, and the final stuff was, I had in the last few IETFs always discussion with folks that said, oh, that system looks nice, but there's one or two things that we don't like we already have some existing schemes for unique identifiers and devices with which we can create addresses, or, we don't like this encryption or that. So it was basically just summarizing how, variations of the ACP could easily be defined proprietary or in the IETF in future work on the different aspects here. Yeah, and then thanks, Brian. 30 more references through the review. So, okay. Yeah, that's it, I think.
Hi, Terence. As a document shifter, may I ask, given the working group last call comments you received, do you need, do you think there's a significant change you should make in the next update? Then we have to do the second working group last call or not?
No, I think after this, the only feedback I received was one or two small points from Bill Edward, and so I think we can put those in anytime, and that would be very small changes.
All right, that's great.
Okay, Brian Carpenter. 2 points. One is just for information. Both this draft and the previous one define some GRASP objectives. So I have written demo code for both, for all three objectives concerned, and proved that they do in fact work and produce valid results. And if you want sample messages in binary, I can generate them for you, for either of the authorship teams, if you want to include such examples. The second point is actually not for Turles, it's for the area director. Is he somewhere in the room?
Just behind you.
Yeah, oh, right there. Both of those drafts and the prefix management draft, which we didn't need to discuss, all three in their IANA considerations define GRASP objectives. And IANA has pointed out already that they need an expert reviewer, because otherwise they're not ever going to let those drafts progress. So we do need at least one IANA expert appointed. Otherwise, all three drafts will sit there forever.
Yeah, maybe just in conjunction with that. So we had some discussions about how to make the GRASP discovery flexible, and you'll see another draft that I have later on the agenda that's trying to pull that all out of the Bruskin ACP things, keep the GRASP objectives in these main RFCs as simple as possible, and then make the flexibility through extensions. So maybe that helps to quicker close on any questions related to those objectives.
Okay, let's move to the next one. The reference model. Jefferson.
Good morning. This is Jefferson, and this will be a really quick update on the reference model. Next slide. So the changes from 04 were first, we changed some normative information about must and should to non-normative language. So this is the first, I think it's the first important change. The second important change in the document was in the management section, when we have more information on the partially autonomic networks, and also very loud. Okay, better.
Yeah.
Okay. So we are also some information on, as I told before, about partially autonomically managed networks. When also some information about the separative informative and normative reference, and some editorial stuff. Still loud? Better? Better? Okay. Next slide. Also, a very important change in the document was about the security considerations, and this is essentially a new section. And one important change from the previous version of this section is that we have a distinction about outsider and insider attacks, and this is something that was really discussed by the authors of the document. So the bottom line on this distinction is that when you have an outsider attack or an attacker which is out of the ACP, we have similar properties to attacks from other systems, other networked systems. And when we have an insider attack, is some node inside the ACP that can use the autonomic distribution functions or functions by the ASAs in order to perform attacks. So here, the important thing is that as an atomic distributed environment, the surface of for an attacker is larger. And this is, I think it's the most important information about this. So we had some discussions about if this text is clear enough as a distinction between these two kinds of attacks. And as a new text, it's very important that we have some reviews and some feedback from the group. Next slide. And so the next steps for this document, we believe that all the raised concerns and the reviews and all the changes required are performed. So we are asking for the work group last call.
Thanks. As a document shepherd, I haven't done the draft review yet, so I'll do that in this month, and afterwards probably need another update. After that, if all those issues are addressed, we could do the working group last call in December, I believe. Yeah. Thank you.
Thank you.
Next will be GRASP API. Brad?
Hi, so that came quickly. I wasn't expecting it so soon. Okay, so this is not the first time you've seen this draft, but I think it's getting to the point now where we really need to decide whether we're going to go forward with this work, and where we need some feedback from people who've really thought about how they might use it or implement it. Next slide, please. Okay, we'll just look at the overview implementation model. This hasn't changed. Autonomic service agents will call a library, which they see as the API, possibly through an extended function library if we add more sophistication later on. And that API library will have to call the core of GRASP through some sort of inter-process communication method, depending on the operating system, because some of the core functions of GRASP have to run in their own process and in their own memory space. So next, please. There's a couple of data structures which application programmers, because ASA writers are basically application programmers, will need to understand. One of them is the grasp objective, which has a name. It has a property, whether it's synchronization or negotiation objective, and it has a loop count, as everybody ought to know, and it has a value. And I just remind you, the value of a grasp objective is anything that you can express in CBOR, which, if you're thinking in terms of an object-oriented language, is basically pretty much any format of object that you want. If you're in C, well, you have to think of the same thing at a lower level, but there's still basically no restriction because CBOR can do pretty much anything. The other thing that a programmer needs to know is the concept of an ASA locator, which is either your own locator or the locator of a peer that you're communicating with. The actual locator component of an ASA locator is typically an IPv6 address, so it could be theoretically an IPv4 address or a URL or fully qualified domain name. You need to know the protocol that applies, typically TCP or UDP, but doesn't necessarily have to be. And you need to know the port if the port is relevant. And there are some other less important properties. So the AP, those are the main atoms that are passed around in the API. Next, please. And this is just a first of a couple of pages of summary of the calls that we propose. Register an ASA so that GRASP knows it's there. Register an objective so that GRASP knows this ASA can manipulate that objective. And discovery, which means discover another remote ASA that handles the same objective. There's one we tacked on at a fairly late stage called send invalid, which you can send at any time to say, I didn't understand that. But that's not really very interesting. Next, please. Then for negotiation, negotiation is symmetrical as defined, but it has to start as a client-server interchange because one side has to tell the other side, I want to negotiate. So there's a request negotiate, which is how an ASA tells another one it wants to negotiate, and there's a listen negotiate, which is how an ASA says, I'm willing to receive request negotiates. But once you've matched a request to a listen, everything else is symmetrical, and there are three options. Negotiate step, which is where you send an objective to your peer saying, this is what I want next. And the peer can reply saying, this is what I'll give you. And negotiate wait if you want to insert a delay in the process, and end negotiate when you want to end the negotiation. And if the result of the negotiation is success, then you have nothing to say, but if the result of the negotiation is failure, you give a reason. Next, please. Synchronization is similar but simpler. You can synchronize an object, meaning I want the value of this objective, or you can say listen synchronize, which means I am willing to hand out the value of this objective to anybody who wants it. And flood is the broadcast, well, the multicast version of this, where you simply send the objective out to all nodes. And get flood is an additional call that someone can use if they want to find out that an objective has been flooded. The way it's defined, if you do synchronize and the value has been flooded, the synchronized call will return the flooded value to you. Okay, next. What we've done recently, we've updated everything to match the approved version of GRASP. We have added a note that a simple node might not want this API because the simple node might have GRASP built into its mainline code. So this is not compulsory. And we added send invalid. Next, please. A few things are missing. I've added a couple of them already in my Python prototype. I haven't yet added rapid mode negotiation either to the API or to the prototype because I find it makes my head hurt because it mixes up the state machines for discovery and the state machine for negotiation. So probably we can add that. It's just I haven't thought it through personally. Next, please. There's an open question. some criticism came back from some people who looked at how they would implement this. There are two approaches to handling the asynchronous nature of GRASP. One is to assume a threaded environment, and this means that quite a few of the calls, because they can run in their own thread, can be blocking calls. Good example is discover, which blocks until you get back a discovery result, which can, of course, take some time. The other implementation model is to not assume you have a threaded operating system, or threaded language, in which case you have little choice. You have to use an event loop type of structure, which basically means that you can't have blocking calls in the API, because otherwise you will block your event loop on each of these calls. There's a model proposed in the API for dealing with that, is if you call something in this mode, which would otherwise be a blocking call, it will simply, if it's not got an answer for you, it will simply give you a return code saying no reply. And when you finally get a call back, you will get back a genuine answer. So you just repeat your call in the event loop until you get back an answer. That's an area where we would really like other people to look at the proposal and the description and think about how they would implement it and tell us if we've got it right, because this sort of thing is difficult to do in the abstract. Next, please. So we need help on a robust mapping of all this to C. It's actually quite easy to map it to an object-oriented language, but it's not quite straightforward to map it to C. And I personally am not a C programmer, so I need help, and I think we would appreciate help on that. And I think that's probably the last slide worth talking about, except should the working group adopt this work as sort of extension of the current chartered items.
Hi, Tolle Eckert. So I think we definitely should adopt this. I'm not sure, if we're kind of with the current text close to, the final stuff, because I just didn't have the time to spend on the details. Yeah, I mean, to me, it's actually the other way around, right? I mean, we should have first defined the API as that's the service GRASP provides, and think about the protocol, but we're IETF, so we're never doing it that way. So, no, I mean, some of the things that, through also the security review and other stuff that I think will impact the API would be to expose, the security properties of the underlying transport that you have, whether, for example, you need fragmentation or, message size limitations, or you have the security. So I think there are some good things to add on that side. Thanks.
Any more from the room? Does people think this is important work? We should adopt it, or that makes sense to you, for you guys? I mean, for me, I think this is very important work. It actually increases the reusability of GRASP, and that will make the ESA much easier. But actually, Terry, I do have a question for you regarding to this document, because that's an API, and that's an API between the functions within devices. So is that right for IETF to define such API? Because that's more interoperating within devices, not rather between devices.
Good question. I want to come back to you on that one because I don't have an answer straight away.
Okay.
Traditionally, we'd like to think about things on the wire, but then...
That's my understanding of it.
Right. But in a situation like this, if the interoperability within the two functions is not appropriate, this is going to impact implementation. So right now, I don't know.
All right. Yeah.
This is Brian. I'll just interpolate that we have done APIs in the past as informational documents, not as standards track documents.
Yes.
Okay. Developers
Well, I would like to say yes as well, basically. So, and when you look at this in the context of network softwareization and the idea that we're going to run many different pieces like as software elements running on a homogeneous infrastructures, precisely this kind of APIs is going to become more and more part of the, let's say, of the network interface. It's not only what goes on the wire, on the air, or the fibers.
Okay. Right.
Okay.
Okay.
So will you ask the question, or shall we do that on the list?
I will ask.
Yeah.
So, I would like to get the sense from the room. Does people think this work is, make sense, and we should, as working group, care about it, whether that's adopted as informational document or a standard track document? We can discuss that later. Yeah. Okay. Okay. So, people who think this work is makes sense and the working group should care about it, please come now. People who think the working group should not adopt it, please come now. Okay, I hear no objection. Right.
So we'd really love to have at least one other co-author who is, an active C programmer. That would help a lot.
Yeah. Anything Terry wants to say?
It struck me that call really just showed a whole heap of apathy within the room regarding this topic. So I don't think there's any judge of consensus there. Sure. Whether this can go forward. So please take that to the mailing list, and I'll be watching carefully. Sure. On that. It's a working group. You need people to be engaged and to work on these things. Yeah.
Yes. Yes. So we'll continue discussing in minutes. Thanks, Brian. Next. Who's next? Yeah.
Good morning. This is Bing Liu talking about the information distribution over GRASP. Next, please. This draft has been talked a couple of times, and while we discussed this in ANIMA, the distribution is a function to handle different patterns of information exchange between autonomic nodes. And it uses GRASP as the barren protocol. But the scope of the distribution is purely focused on the information exchange itself, rather than some logics to be achieved through negotiation or synchronization. So it can be also considered as some extension to the GRASP protocol. But essentially, it is a function, and there should be a separate module to handle the distribution function. Next, please. So if we see this in the API view, just as Brian mentioned, there could be some extended function based on GRASP. So that's the information distribution position fits into the ANIMA's architecture. Reference model, sorry, no architecture. Okay, next please. So the current draft describes some very basic patterns. The first one is flat. The most relevant scenario is to distribute some global parameters to all the autonomic nodes in the domain. this is already covered by the flood message of GRASP protocol. So this function doesn't need any extension. It's already there, just use it. And there's some optimization for the flood, which is called selective distribution. This special function can reduce some unnecessary traffic, because when a node want to distribute some information, it will examine his neighbors. If the neighbor fulfill some condition, then it will send a message. Otherwise, it will just drop the message. And we had some use case discussion in last year in Seoul. And this function needs some new objectives definition. We call it a selection criteria to let the module knows in what conditions they should decide to send the information to the neighbor or not. And the third one is in a real deployment, the devices will get online incrementally. So some information just cannot distribute to all the nodes in just one time. So if the node can detect whether there are new neighbors come in, then it can send a message actively to the neighbors. And actually, we will need a new message for this function because in current GRASP, there's no message that one node can actively send something to another without any previous request. So we need something called unsolicited synchronization. I think this is also a simple extension. Next, please.
Hi, Hi, Bing. As far as I recall, you did present the use cases back in Seoul. But during that meeting, we don't have enough time for many discussing. So, what feedback you may receive afterwards, offline, or?
You mean the selective flooding
Yes.
use case discussion?
Yes. Yeah.
We haven't received any essential feedback, but during the discussion, I think in the room, people had the consensus that the selective flooding is something useful. But we can raise some more discussion in the meeting list.
Yeah, that make me concerned. We need people to confirm that's a real use case, and people would like to use that function after we define it.
Yes,
Yeah.
sure. So if I do a summary of the current distribution function, is mostly regarding to pushing some information. Why not just push it to the others? But how about why not just collect something, pull something? I think this should be also in the scope of information distribution. So in last IETF, Arthur gave a nice presentation about integrating pub/sub mode into the ANI. So personally, I think this is important work, and we should consider to do. Okay, next, please. And it is even better if we can integrate some simple transport function. We can make the signaling protocol some built-in features to do simple transport. And Brian had a new draft, and he will talk about later. Next, please. Okay, so in my opinion, this is a more complete picture for the information distribution function. And there are several extensions need to be done. The first one, the selective flooding and unsolicited synchronization pops up, and the bug transport. So I think with these more complete capabilities, the ANI can provide a kind of full function to the upper layer ASAs. And the self-contained mechanism can reduce the code space. And more importantly, it means we don't need any other pieces of protocols to be combined together to provide some function. We just use a single protocol or single modules just within ANIMA's scope. So I think this is meaningful. Okay, next please. Okay, so the question to the working group, do you think this information distribution is something we need to do in the future in our working group?
I'm going to join Mike. Okay. Dennis, are you going to run for Mike? Okay. Good.
Paul Seckert. So I think we need to do it. I'm just not sure exactly, how and how much of that would be in Charter, right? So browsing through the draft, I think it's a good start with the, requirements. It's not really, I think, conclusive as a proposed solution. And I think what might be, already in scope of the Charter is trying to figure out if we're missing in GRASP itself core things that need to amend it to support this. But I would hold my, my judgment also after Arthur's presentation, because I think it goes in the same direction with a different terminology and everything. So maybe more discussion after Arthur's presentation might be useful.
Okay, thanks.
Hi, Arthur Hecker. So I find it extremely useful in the sense that we have in the reference models information distribution, so somehow we need to do it. However, indeed, I do not care really where it's done in the sense we need to implement it somehow. Whether it's GRASP doing it, okay, fine, let's do it in GRASP. If not, then we need to do it on the top, right? And these are the issues we are trying to discuss since the last time. So I really do not have any preference. Let's find the best fitting place for it, but somehow it's in the reference model already. So I do not see how it cannot be done.
For me, actually, first, the information distribution work is definitely needed. But how we process it, I'm thinking first, the current format of this document is still very primary. Mm-hmm. And for now, it seems most of this document is focused on the requirements. And also, actually, you haven't really covered the PubSub and back transport within the current form yet. I'm thinking maybe the best way would be first to make a requirements document. And I know earlier I said, I may want, integrate document to do both requirements and the solutions. But actually, giving, you're talking about multiple solutions, so that may make sense to do, integrate requirements first, as informational document. Then you have each of those functions separately later. Yeah, and Terence and I will check, how much this is, within the current charter. Personally, I believe that's mostly match the current charter because that's still giving some function which can be reusable for most of the autonomic network functions. Whether we do that in the pure grasp extension way or make it as some generic autonomic service agent, that's another matter. That's fine. Either way. Yeah.
Yes,
Okay.
I agree. Regardless of its ASR or some grasp extension, I think the key point is to separate from the grasp basic protocol. We don't bother the grasp process.
Yeah. If possible, we would like to reuse whatever the grasp already defined and try to minimize the modification directly on grasp. Right?
Yes, sure.
Okay. Thanks. So next. What's next? Should be some.
Okay. Good morning, everyone. So I would make a presentation on the guidelines for autonomic service agents. We have joined this draft recently in the last iteration. It was a work initiated by Brian Caperton and Sheng Yang. Next slide, please. So this is just the agenda of the talk. Start with what we want to achieve with this document, then go through an overview of the structure, the recent changes, the main points for attention of this presentation, and then a quick discussion next step. So what we want to achieve first with draft. The main idea is, first, who we target. Our targeted user and reader of this draft are the developer of the ASR or autonomic functions. In ANIMA working group, we have been working a lot on the protocols and the ANI, GRASP, etc., which are all protocols to make it run. But there will be, we expect a lot of people, an ecosystem of developers developing autonomic functions, autonomic service agents in the ANIMA terminology. And so we want to address their needs because they will not necessarily be experts in the ANIMA protocols. They will more probably be experts in the functions, the autonomic functions they would like to design and or they would like them to operate. So essentially, Brian previously presented the draft on the API, which is a first step towards extracting the cores of GRASP towards a developer community, but it will not be enough. So we want also to, in this draft, expose practices, guidelines, how developers, what they need to focus on, what they need to concentrate when they are developing their codes. Next slide, please. So this is the current structure of the draft. There is first an explanation or details on the logical structure of ASR as defined in ANIMA. Then important part on the interaction within the autonomic infrastructure, the ANI. A chapter on the design of GRASP objectives, the relationship on the ASR are structured and how they need to capture the GRASP objectives and handle them. A section on the life cycle of deployment and installation of ASR. A section on coordination, which is still empty today and to be discussed. And robustness section and security considerations. Next slide, please. So recent changes. There have been more details provided on the event loop scenario. Currently, the assumption, I think this comes later, but okay. More details on the event loop scenario, which was included. Clarification on dry run usage in the draft. A new section on the life cycle, and this is what we came in for, and a new robustness section. Next slide, please. So the main points, there are a number of assumptions taken in this document. So first, the ASR runs within the ACP. and they use Grasp for their communications. But there are also a number of aspects that needs to be covered. So assumption is that ASA essentially should be a multi-threaded software, but you can also rely on a more event loop approach. But you have to incorporate that there needs to be a certain set of processes running in the ASR by default. It must be self-monitoring and self-restarting. In case of failure in the operation of the ASA, it should be able to identify it by itself and try to different ways of restarting the process, its own process. There should be threads for handling the different processes related, for instance, to Grasp, for the flooding, synchronization, negotiation of objectives, but also for other housekeeping functionality to manage other potentially non-autonomic devices. Next slide. The Grasp objectives follow the Grasp rules. This seems logical, but Grasp currently provides no transactional integrity, so it will be up to the ASA developers to handle what happens in terms of logs and atomicity of all the operations. So this is to indicate in the draft what is the responsibility of Grasp as a protocol, and what will be the responsibility of the ASA or the developer of the ASA. The value of an objective in Grasp is only limited by the CBOR format, so it can be virtually any data structure. So this is the section on the lifecycle. This is the first time in this draft. So since we imagine that the ANIMA network will be continuously evolving and reconfigured, there needs to be a systematic lifecycle in order to install, instantiate, and operate the different ASA running. So description of a short lifecycle and aspect related to this lifecycle for the developers. Next slide, please. So this is also just a quick introduction of the draft. We are welcoming questions and feedback on this new version. And of course, if you think it's relevant, this will continue as a working group document.
Bing Liu. First of all, I think this is useful document, and I have two specific comments. The first one is you mentioned in general the ASA should support multi-thread, but in some very constrained devices such as the IoT nodes, maybe you can also have some description of very tiny ASA. It just has one thread and one very specific objective. So in that case, the ASA could be very simple and don't need any multi-threading. That's the first comment. The second comment is in the NFV scenarios, there's a concept of microservice, which in my opinion is very similar to the ASA concept in ANIMA. So maybe there's some explanation between the concepts, similar concepts. In my point of view, I think they are essentially the same. Maybe we can have some discussion on that. Yeah.
Sorry, which context are you comparing to?
In NFV, Network
yeah.
Function Virtuality, there's a concept of microservice. In my opinion, it is just essentially the same with ASA concept.
Okay, so I'll try to comment on your comments. The first one, which was on the multi-thread. Yes, for sure. It's what we are currently in the draft are our own assumption, and there is also the introduction of the event loop approach. So for sure, depending on the requirements or constraints of the different ASA and environments in which they will run, this is not to prescribe any mandatory implementation to the developer, but it's just to give guidelines about what they should really care about when they're developing their own functions. It's sure if there are really constraints, they will concentrate on having efficient light code, etc. So they can rely on maybe a single thread or event-oriented approach. But they should be aware that behind that Grasp, may behave asynchronously, so that you should not lock the process of grasp because you cannot only handle it in a serial manner. And the second comment on NFV, I think this is a more general discussion we need to have about this draft, but more about ANIMA autonomic functions. If we expect this to be software, just software, pieces of software, yes, there are some other contexts like NFV, microservices, but any kind of embedded code, we should get best current practices and see what are the specificities of autonomic networks we need to describe in those drafts. For instance, like coordination, the life cycle may be specific. The fact that they are running in closed control loops may be different from other environments. So this is what we need to capture, and not to reinvent the wheel. If there are very good practices for software development, this is not the goal of this document to do that again.
Thomas Eckert. So I'm not even sure if I should, if this is a comment from an individual or as a working group chair, right? So I think the first thing is that I'd be worried that this would be considered to be outside of the current charter scope, right? Given how it deals with ASAs. Secondly, obviously, you know, I think this is interesting and should be done, but we'll need to figure out, you know, how and when we do it, you know, with rechartering or so. Thirdly, the question is always a little bit what the IETF likes to do, and there seems to be some, you know, distinction between things that, you know, are done on interfaces called APIs versus interfaces that are called, you know, Yang. And so I think we discussed also in some of your prior drafts that this may be potentially easier be accepted by the IETF if it's seen as, for example, starting on dependencies between, you know, different data models that are representing what a particular ASA is doing, right? As opposed to starting it from the typical software development perspective, right? Thinking more about the data modeling aspect of these different ASAs and how they interact with each other, right? Maybe that's also another approach to think about how to get more acceptance in the IETF, because there seem to be, you know, specific things they like and they don't like. So I think this is all stuff we need to work through.
Okay, thank you for your comments.
Yeah, Brian Carpenter. I'm a co-author. Microphone disaster there. I'm a co-author, but I would like to say that bringing up the NFV point is a good one. We do need to think about that, because if we propagate one religion and NFV propagates a different religion, then, you know, we're going to end up in trouble. So I think we really should take that point rather seriously. I'm not particularly worried about the problem of very simple ASAs. As I said in the API discussion, they might not even need the API. You know, if a very simple ASA has its only interaction with grasp might be to listen to floods, right? Which is probably 1/10 of the API at the most, very simple and straightforward. So there will be cases where all of this discussion is beside the point. So I think we're probably in this draft focusing on what you might think of as high-end ASAs, which are relatively sophisticated, which really are application programs. And if somebody decides in the end that it's out of IETF scope, they will publish it as an independent submission, RFC, I guess. But you know, I think we are genuinely worrying about having an ecosystem built on top of the infrastructure. And that's why this draft is a little bit difficult to position.
Developers, it's just a reflection to this mention to microservices. I find it dangerous that we start reflecting this in those terms here. We're talking about, we're talking protocols, we're talking data models, we're talking even in some cases APIs. In my understanding, the microservices is a software development pattern, and that would be dangerous to introduce them in this discussion.
Yeah, I understand, and I will say agree so far. But the point for me is more on the assumption we take to progress this document. If so far we have worked a lot on ANIMA on the supporting protocols, I will say, ACP, GRASP, etc. But we have not talked a lot about the ASA themselves. we need to better understand in a group what we think those ASA will be in terms of softwares, a piece of software. And then if we think that there will be a really standalone, big pieces of software, that maybe they will not be suitable for microservices. But you can have ASA that can be implemented in a microservices approach. I just want to make the distinction is that for the working group, we need to understand what we think ASA will be designed like, and then they will be supported by different software patterns, as you mentioned. Not to say that every ASA should be implemented as a microservice. I don't think this will be a mistake. But to say that if they are implementing a microservice, we need to understand what will be the impact on the design of the ASA and what guidelines we should provide to the ASA developers. That maybe they will not understand anything about microservices, but to understand that if they want to achieve some level of parallelism or distributivity, they need to understand those needs.
Probably this is the typical case precisely for a hackathon activity, or for some kind of implementation statement or something like that.
Yeah.
Which is, I mean, but keeping it somehow isolated from the rest of it.
Shing, without my working group chair hat, actually I'm co-author of this document, but I would like to take the discussion wider than the document, to be, how this working group should, care about the ASA, because, for me, we are only so far we are only defining the autonomic network infrastructure and the components, but to be able to make them useful, there should definitely be the autonomic service agent. But actually, if those agents, very specific for very narrow scenarios, I believe that's out of the scope for this working group. But if there are two categories. One is this working group should care about how to make the autonomic network infrastructure and its components to be easier for the for the implementations or for the operators to use. I believe this document is one of those efforts. Second, if there are some generic ASAs which can be used for most of scenarios or cover multiple scenarios, then that should be considered something between the extension of autonomic network infrastructure and ASAs. So such ASA may be considered by the working group. Actually, giving an example, even the SAP and the Brodsky could also be considered as one type of ASA as well.
Mm-hmm. Okay.
Alex Callis, I would like to make some comments about how to extend this work before it's too late. Assuming that there will be many ASAs, sooner or later, the problem of coordination of all of them is going to be fundamental. It's not something which will be easy to add afterwards. Therefore, the coordination and orchestration of these ASAs, in some sense, have to be added to the problem from beginning, like a northern ecosystem for these older ASAs. And I didn't see that how this is done in your part, but it should be, in my view. Second, in order to be practical, this ASA should have a level of recursiveness. In other words, to build some ASA from other elementary ones. And this recursiveness should be one of the items in your life cycle, in some sense.
you really mean recursiveness or modularity in the atomic functions?
Probably it'll be with both. And finally, it's in order to make ASA, sooner or later there'll be a need for each ASA to have distribution or data distribution capability, which means that this has to be linked fundamentally with the other draft. And the two parts have to come together in order to be successful.
Okay.
But these are additions, if you want, or something which could be added to the overall scope of the draft in order to make it a bit more concrete. And finally, I still am not clear about, even if you have 100 million ASAs plus all the other things, how you configure it to make a network. This some sort of reference configuration for ASAs as a group or part of a group maybe need to be looked at to make it realistic, either per use case or for other situations, like in NAV especially, clearly this is absolutely needed. These are my small comments to be added.
To come back on your comments, the first one on coordination. So there is currently a section in this draft, and I mean, we have in the plans to try to fill it. There was previously in ANIMA an individual draft on coordination. So we welcome anyone willing to contribute to this. I also think coordination is important. I don't know to which extent it should be in this draft or in another item for the working group. Concerning the comment on recursivity or modularity, my understanding will be to say that if we can, in this draft, show what are the modular parts of an ASA that can be reusable for any type of ASA, I think this can be useful. For the recursivity, I'm not sure I can understand it right now, but it can be discussed. And the last part, when you were mentioning a bit the aspect of configuring the ASA to make a running networks. So the lifecycle parts start to touch on that, how to deploy, install, instantiate ASA to achieve a given goal of the operator. And I think we are also having the ANIMA working group discussion, but not this session, but the aspect about deploying and configuring ASA through the aspect of intent. But I think we had already discussion on that. It's a bit paused for the moment. We are discussing how to address this work, but I think addressing a more general approach to configure groups of ASA can be linked to the discussion on policy or intent. Not necessarily only this, but it has been discussed in the past on this aspect. Okay. Next.
Brian Carpenter again. One quick comment on that last point. If we really succeed with autonomic networking, the word configuration will no longer be in our vocabulary. So I think the end point should be indeed that the intent and the policy associated with intent is all we need. And we actually don't care anymore how the network is configured.
Thanks,
Thank
Arnold.
you.
Brad? Yeah, again. Okay.
Okay, I think this is the last time you'll see me today. Next slide, please. So I'm going to talk briefly about this new work, motivation, what the proposal is, and discussion of some issues and next steps. Next, please. So GRASP was designed around the notion of an individual technical objective, which is a relatively small data structure that can be sent in a message We set the message size limit to 2K, so it's, you know, it's not an enormous piece of data. However, as we heard from one or two other talks, an autonomic network may need to distribute larger data objects. Think of them as files or whatever you like, but things that are clearly not going to fit into a single message. There are many ways to do that, right? There's this thing called HTTP. There's this thing called FTP, and you know, we know how to do this. The draft that I'm talking about investigates using GRASP itself for this if, in a particular scenario, we want to limit the number of software components that people have to install. So there's no assertion that this is the way to do bulk data distribution. This is simply a way you could do it without any other protocols. So next, please.
I would like to make a comment here. Personally, I actually like this motivation very much because at the very beginning of ANIMA, we said if that's possible, we would like to have GRASP as the signaling protocols. Actually, there, you know, in the real world, we actually had IoT scenarios. We already implement GRASP as the only signaling protocols, and we actually even use GRASP, modified GRASP as a protocol for network management. I'm not sure, you know, how this, you know, accepted by the working group, but you know, that was in my personal ambitions to be the protocol. Thank you.
Okay, so the basic proposal is to use GRASP negotiation, which remember is a backwards and forwards process with any number of steps theoretically possible, but use that negotiation mechanism to transfer your bulk data one block at a time. So the communication model is slightly asymmetric, as you'll see, compared to a traditional GRASP negotiation. And the goal is simplicity, not performance, I should emphasize. If you want high performance bulk data transfer, this is not the solution. So procedure looks like this. The client, we have to make it a little bit asymmetric. Think of one of the sides as a client, the other side as a server. The client discovers the server using standard GRASP discovery and response. Then the client requests the file that it wants by sending a negotiation request, and the value of the objective that it sends is the file name, if you think of this purely as a file transfer mechanism. The server sends back the first data block, which is simply a negotiation step using the mnegotiate message. And the client acknowledges it with another negotiation step in return. So you see the asymmetry here, that on the message from the server to the client, the value of the objective is actually a data block of the file. On the message from the client back to the server, the value of the objective is, well, I suggest the string ACK, but it could be anything you like, as long as it's understood to mean acknowledge. And you repeat steps 3 and 4 until you reach the end of the file. Right? So it's very straightforward. Next, please. Just a few details. The data block size is chosen to fit into the GRASP message size. In the toy version, I used 1K as the data block size. At the end of transmission, the end of transmission is signaled by sending a standard GRASP end with an accept code. If you get any kind of error, you send an end with a decline code. And if you want to, in the decline message, you can add a reason, but you don't even need to, because the other end knows what's happened. The transfer has failed. We rely on TCP or UDP checksum for avoidance of corruption. And in IPv6, UDP checksum is obligatory, by the way. You detect missing blocks by timeout because GRASP negotiation steps all have a timeout. And so if the step times out, you never got the ACK or you never got the block, then both ends know that the process has gone wrong. And in the simplest version, if there's any kind of failure in the process, you just start again, right? So I said it wasn't efficient. Okay, next, please. Does it work? Yes. I implemented it, of course, using objective, which I called 411:move file. That's the GRASP objective format for a local use objective. 411 happens to be the magic number that belongs to the University of Auckland. And so that's a unique objective name. I've been using it routinely to move files between a Windows machine and a Linux machine because it's easier than using a thumb drive or pushing them up into GitHub and pulling them down again. And the client plus the server come to about 215 lines of 215 lines of Python. So it really is very simple and straightforward. Tell us, do you want to go now?
Just a question. So I have a couple of ASAs between two nodes. They're doing some things, and now I'm bringing up these two ASAs that want to do the bulk transfer.
Mm-hmm.
I'm still a little bit confused about the multiplexing of Raspberry. Would there be any risk of head-of-line blocking in the other ASAs?
I don't think so. I mean, it's asynchronous, right? And because I'm a Python programmer, I use threads. Now, if I was
I
I
mean,
was using Bing, I wouldn't be using threads. But no, the transactions are they're just completely separate, independent sessions. They run in parallel.
So those would be on separate 5 tuples, right?
Yeah.
Yeah. Okay.
Yeah. So, I mean, you remember because we use TCP, then you actually get a new port for each negotiation that's in progress. So you could have 100 negotiations in progress on 100 different ports, and they're all independent.
Right.
Of course, you could get head-of-line blocking
No, I mean,
in the interface.
So that eliminates my concern for me not being fully clear on the details. So, whether or not ASAs would like to use some existing file transfer standard, or, we come up with a new one like this, I'm not sure how to make a choice between that, right? So your justification is a simple, some applications may want to use it. So I think it would be good to have more brainstorming on the justifications, pro and con.
Sure,
right?
but that comes back to what Sheng said. There are scenarios where this might be simplification of your software environment. There are scenarios where it might not, because you're already running, NFS. Mm-hmm.
Bing Liu, a quick comment, echo to Torres' question. I think the GRASP has this transfer capability, not only simplification, but also can reduce some extra configuration. Because if we use other FTP, TFTP, it implies there are some extra configuration. So if we build in this, we can avoid such.
But on the other hand, if you decided to use HTTPS for this, then as far as I understand the Brewski process, there's going to be HTTPS in all the nodes anyway, because they use it, right? So there may be cases where it is not a good idea, and maybe the opposite. Sheng.
A clarification question. So you are proposed a new generic function without extend any standard GRASP, right?
Well, this is a first draft. I mean, I decided to implement it to see if this syntax for locally defined objectives worked, right? If you'd like me to put in an IANA considerations and use a generic one, I can. But this is very preliminary test that I did. Yeah. So we could write it as a general purpose thing. Yeah, absolutely. I simply didn't do so for the first draft.
Yeah, I'm concerned, how we may categorize this into informational or standard track.
Yeah.
Because for me, if there's no grasp extension, so that make perfect sense to be a validation use case, be a informational document.
Yep.
But as I said earlier, if that's possible, I would avoid to extend grasp to do any new message.
No, if we take this forward in the working group, I would assume we try to do a standard version, whereas I just built a toy, which took about an hour, by the way. It was very easy work, and did it this way.
Right.
Okay.
Thank you.
Could somebody put up the next slide? Okay, so we got some feedback on this from Joel Halpern, actually, and he raised 3 quite interesting questions, which are really questions about how general we want to make this, right? First of all, what happens if you wanted the client to request an upload instead of a download? That would be a fairly simple transformation. It would just invert the logic very slightly. So the data blocks would flow one way and the ACKs would flow the other way instead. So yes, we could certainly do that. More seriously, Joel made the argument that we really should add in a position indicator or a block number indicator because there's a risk of getting out of step. Now, I maintain there isn't, because actually grasp negotiation is a strict handshake. My turn, your turn, my turn, your turn. So I don't believe there's any way we can get out of step, because if a block doesn't arrive or if an acknowledge doesn't arrive, you know that you've lost the transmission. But Joel made the argument that that's not good enough and you should include the block number, which would of course be a trivial change to the protocol I described. The third one is more difficult because he said, well, you can't assume things are going to work in real life, and so you need to be able to resume a failed transfer, which you could do if you added a block number. You'd have to add a little bit more protocol machinery if you were going to resume a failed transfer rather than restarting it. And then I thought, well, am I really going to implement the whole of FTP functionality in this? Because if you put those 3 things together, then, well, why not also implement passive mode? And you could do practically anything. So the question is whether we would want, if we take this work forward, whether we would want to keep it very simple and accept that it's inefficient, and in failure conditions it would be really clunky and slow, or do we want to make it a fully featured protocol with all the bells and whistles that we know about? So that's an open question for me. If there's any interest in this work in the working group, we'd have to address those questions. So next, please. That's it. The question is, should we discuss this topic?
This is Jefferson. Brian, I have a question about the security considerations for this protocol.
So the what?
About security.
Well, my assumption is that I'm running in an ACP, and in an ACP, we have no man in the middle and we have no spies. So I think the security is taken care of by the ACP assumption. As I'm running it on my desktop at home, there is absolutely no security whatever, and if you were on my network, you could do whatever you wanted to my packets. But that's the point of having an ACP.
But do you think that it will be difficult to have another layer of security, something like an user password, something like this?
I honestly don't see why in the enterprise scenario, which is the ANIMA target, but maybe I'm being a little bit naive about that. But if this isn't secure, no other ASA is secure either, as far as I understand it.
I hope nobody expects me to answer to that question right now. Sorry, I was trying to talk about something else. So, if we keep this information, it sounds like a good, recommendation for, how to use GRASP to do something that, many GRASP applications would want to do. And I think that should still be, in charter for the GRASP charter item. But of course, that's something to be discussed with the AD.
He's just behind you.
Yeah, I know. No, I mean, the only thing, since we started GRASP and then, at least for the ACP or so, arrived at the conclusion that we're, going to not doing the unicast at all with datagrams, but just with the, reliable transport connections, hopefully even secure. The question is a little bit, is the segment limitation in GRASP as we've defined it still, viable, beneficial, or should we rather, even think about updating that and saying, hey, why don't you simply have a single GRASP object like a bloody HTML header and, you have your 10 gigabytes of data as a stream inside of it? That would be the only competition, in my opinion, to this approach.
Yeah, and that wouldn't actually change the approach very much, because I think you'd still find that you wanted a bit of acknowledgement and so on in a bulk data transfer anyway, unless you just trust a TCP as well as just trusting the ACP.
Yeah, I mean, if it's good enough for HTTP, I don't know. I mean, what the bar is to basically argue that a segmented, multi-acknowledgement thing is required beyond TCP. I don't know where you start that, because HTTP doesn't do that, right? So
yeah. And this isn't too bad, by the way, because a GRASP negotiation session opens a port, opens a socket at each end, and holds it until the end of the negotiation. So this is a single TCP session which is being used for all the transfers.
I'm just saying we should talk with the transport layer person to see if we can find arguments pro or con this approach to conclude on this point.
Sure.
So putting on my AD hat for this, it's interesting and it's cute. My question is, does this inhibit, or is it a blocking aspect by not having this to the deployment of autonomic networking? Does this fill an absolute requirement somewhere?
Well, we have this set of problems that are being talked about for distribution, right? And we've stopped talking about intent because we don't know what it is. But the fact is, once we do know what intent is, we will need to distribute it. So we need something, right? I'm not saying we need this. I'm just saying, well, we could do this. But if we don't have this, we'll have to use some other solution for the problem, which, could be TCP, as Till has said. That would be radical. Or we could use, HTTP, or, so there are a number of solutions. I think this is just something we need to have in our minds as something we could do. Whether we should do it is still a slightly open question, though. Sheng, I think, has some scenarios where he thinks we should do it.
Right. So there's obviously an open question there about could versus should.
Yeah. Could is clear. I can do it. I can show it to you if you have Python on your machine. Right?
Absolutely. So the benefit to this really is that you're using GRASP to bypass adding extra layers, extra machinery in autonomic networking.
Exactly.
Okay.
Echo to our AD. In my mind, there are at least two use cases. First one is at the initial stage, one device and join the domain. Normally, it will download some image for it. So in that case, if GRASP can provide such capability, then no other configuration for the dedicated transport, FTP or TFTP. That's one case. The other one may be a longer. The ASA itself could also be delivered. If the ASA itself is some kind of small software, and it could be dynamically deployed on the devices. So ASA itself could be transferred by GRASP. Yeah, just to simple use cases.
Closer to the mic, please.
just paraphrasing, he just described two simple use cases. One was about configuration, and the other was about dynamically assigning function through basically an image. So, that has a nice play scenario in IoT and the things that are happening in suit and so on and so forth. But okay, I'll allow the discussion to continue. Thank you.
Very, very short remark. You started talking about the could and the should, etc. My only concern is that this doesn't become a must. I mean, is that as long as you can use GRASP to send references using other protocols, for whatever the reason, I mean, because there is another API that you want to use, etc. I think there is a value on this, definitely.
We'll continue the discussion in mailing list. Arthur, next.
Good morning, everyone. I'm Xun, and Artu is also here, so we both can answer your questions if you have any. So it's a little bit surprised that being already mentioned that information distribution is very important for the autonomic networking topics. So here's a little bit more details and our thinking and idea about this part. We are kind of proposed our alternative and mechanism for how to do the information distribution. Next slide, please. So this work is actually for the, of course, autonomic networking infrastructure extension and try to propose usable components for this working group. Next slide, please. Okay, this work is also following our last presentation about PUBs and subtopic. So here we this time we propose to include a kind of event service into the autonomic networking as a reusable component. Next slide, please. I think everybody is more or less familiar with the node reference model of the autonomic networking infrastructure. So actually our kind of autonomic function, including several ASAs running on top of the autonomic control plane, to give our network services. So I won't put too much details and times on that. Next slide. Okay. Currently, according to our investigation and study, we found that the communication model in the current autonomic networking infrastructures is kind of a tightly coupled client and server model, which means that our autonomic function, our sender will directly send a message to our destination node. So for example, we can, from the GRASP, we can use it for the dynamic peer discovery and state synchronization, and also parameter setting negotiation, something like that. And it's all about you want to send some message and request some information from the other node directly. But this is not all the cases in the autonomic networking scenario. Actually, we found that possibly in sometimes the destination node is not available, and also some kind of requests and the communications is not instant. For example, you have to wait for a while. So for those kind of scenarios, there is no any kind of solutions covered by the autonomic networking so far. Next slide, please. Okay, here also mentioned by Shen that we kind of need a very strong requirement and why we need another kinds of communication models in autonomic networking infrastructure. Here, we did kind of investigations and see some scenarios or examples might need new communication model, which is asynchronous communication. So here we put 4 examples. The first one is that the replying of the other node of the destination takes longer time than the direct communication. So for example, if our autonomic function wants to ask the other node to do some database search or lookup, it may take longer time than the simple direct communication model. So the second one is that what if several autonomic functions wants to share some common information? For example, in the information distribution draft, we mentioned that the intent of the network has to be distributed across the network. So in that case, some shared information or interest has to be distributed across the network. And the third one is that probably the autonomic functions in the network may have their local views, which is different from each other. In that case, those autonomic functions have to collaborate with each other to do some network scheduling or to make some decisions. In that case, with the local view of the network, how could they converge to a common view of the network? In that case, they have to constantly exchange and synchronize their local information together. In this case, we also need kind of an information storage, for example, pulling some information from other nodes mentioned by Bing. The third case that sometimes some information has to be calculated before it can be used. For example, we are the sense of the network, and the autonomic function has to come up with kind of collective decision. What is the average of what is the average temperature? What is the average value of the whole network? In that case, we have to collect the data and do some calculations and put it somewhere. Okay, next slide. So in general, here we found that in addition to the direct communication model, which is already covered by the current autonomic networking reference models, how about we introduce some kind of indirect and asynchronous communication model, which is event service. So here, in addition to the current synchronized model, we propose to extend with event service, which means that two interacted parties will be decoupled, and the sender can publish some information, and the receiver who are interested in such information can just simply subscribe that information. And the event service module, the reusable component, will be responsible for handling that information.
Just a quick question. Is there any specific, difference in functionality that you assign to the term event service versus pub/sub? Because pub/sub is clear to me, but you're using the term event service, and it's not quite clear how.
Yeah, exactly. Yes, you are right. Pubs and sub, here the event service, in our opinion, is to enable the pubs and sub. So pubs and sub should have a kind of event service so that it can do the asynchronous communication. So we're not saying that this is the replacement of pubs and sub. Actually, it is for pubs and sub.
And you're concentrating on the event service because you're trying to provide an infrastructure where you could also do other things than a pub/sub on top of it?
Yes, but primarily for pubs and sub, of course, asynchronous communication.
I'm a fan of pub/sub, and I would love to discuss that very much, but I'm still trying to understand the need to go into the details at this point for the event service as a specific approach to do that. So that's where I'm also confused.
I would not put event service as a kind of approach. It's kind of, in our opinion, it's kind of mechanism and also a component that could be included in autonomic networking, so that the upper layer, autonomic functions can share that reusable component to do whatever they want. Or could you please continue to the next slide?
Maybe also answering directly. So usually when you have pub/sub, you need some kind of decoupling between the sender and the receiver. So you need some intermediate party to essentially store messages or backlog them or whatever. And that's essentially our way of saying, okay, we can call it event service, we can call it pub/sub service, I don't care, it's just a name. It is an implementation component to enable pub/sub.
Yes. Okay, move to the next slide. Thanks. Okay, here we just simply propose kind of alternative ways to include such an event service how to include that event service in our autonomic networking. So the first, of course, is we can develop such an event service as an individual or customized an ASAS and included two different application, autonomic application and functions. This is the first way we see. The second way, which we prefer, is that we may have to include such include service component or module into our autonomic network infrastructure. In that case, we may have to, define in a common way that we should have such a module, and we somehow need to extend, as Brian saying, that we may somehow associate that part with the graph APIs, so that the graph can also use that part for asynchronous communication. Okay, next slide. So here's just a very scratch view that what if we include the event service into the current autonomic networking infrastructure. So here we added the yellow box over there and the APIs, and on top of the grasp and Brisky, so that the upper layer autonomic functions and ASAS can or share that reusable components for example, as being said, for information distribution, but in a very asynchronous way. So basically that module has 4 jobs. First of all, listening to the network from the ACP domain, what kind of events are published. And the second, it will notify the other ANIMA node, for example, the autonomic functions, with a certain event. And thirdly, it will handle the local event publication to the network. The fourth one is very important. It's not only just responsible for notification and subscription, but also responsible for storing that information across the network. So 2 major jobs, event service. Here I put the event queues over there and also the information storage. Okay, next slide. Here's a kind of those components will be impact by our current proposal, but I won't put too much time on that. Okay, we actually didn't put the page that raised the question, should this working group consider such a topic? But this is what we would like to ask everybody here, and yes. Finish.
Actually, we can bring back the discussion regarding to the whole information distribution. Yeah.
Yes, actually, we are seeing that this is more or less a complement part for the information distribution, because here we put more requirements and possible use cases and kind of possible solutions for that.
So if I think about both Bing's and your drafts, right? So if I try to cut the cake into 2 pieces, the one piece to me seems that we have things that is meant to be long-lived data distributed in the network, like intent, which everybody needs, right? So the first piece of the cake. And we currently don't have the scheme whereby, the network gets partitioned, new parts come on, and it's there. But in the end, we still want to have, the flooding, but also keeping it persistent, right? So maybe that's one simple thing to say that that can come with a simpler solution, either GRASP extension, simple, GRASP ASA that does the reflooding or so. And then the other much cooler, much bigger issue is that you're starting to have a lot of interesting ASA data sets that not everybody in the network needs, for which you need to set up things that, well, in my prior life, I would have called multicast distribution trees, right? And that would be cool, but I think we need to find a lot more, support for doing this, right?
Yes.
In terms of, there are these, there's, unfortunately, Alex ran out, so, but there are folks been working on distributed data store, also with Yang in the IETF, and those might be, adjacencies that we could work with to establish an infrastructure to support those things, to create the use cases. Because I think at this point in time, obviously, that bigger scope would be much less arguable to be in charter than maybe just the simple extension of just making sure that the flooding that we have in GRASP can be kind of more persistent.
Yeah, okay, I see. But here, what we see is for the event service is kind of glued for all the components you mentioned before. For example, distributed databases and some kind of asynchronous communication requirements. This event service glue them together. This is what we are saying.
We're just not having a, we don't have a structure in the IETF to create more shareable infrastructures, right? If you look at how flooding has been reinvented by every bloody distributed routing protocol, right? I mean, that's insane, but that's basically IETF, right? If we want to make any progress and change that, it's going to be difficult, right? That's...
Okay. Thanks, but.
Bing Liu, one question. If I understand correctly, there are actually two modules. One is for PubSub, and the other is for distributed storage.
You're right. Yes.
So they are
the event service module will handle that two parts.
Okay. So are the two parts totally separated, or they need to be bound together?
Actually, it depends. So if the event service has the full control of the storage of the network, then they are together. If the event service module only has some kind of access rights to those storage, then they are decoupled. But anyway, the event service should be able to use the network storage in ANIMA's domain, if it has, I mean.
Okay. So personally, I'd suggest if we follow the way to make some extension to ANI, then maybe it's better to make them as two modules.
Mm-hmm. Okay.
They are open to the upper layer.
Exactly.
It depends on the ASAs. If they want to use both of them, they just call it. Maybe they only want to use one of them. So,
Yes.
And I think this is very valuable, as I mentioned in the presentation. So whether it's to merge to the distribution draft or we make a separate document, let's discuss it later.
And personally, we don't have any preferences,
Okay.
and especially if we can merge into for example, your information distribution, that would be even better. So more or less, we have some overlaps, right? Yes.
Okay, thanks.
I'm conflicting opinions here by myself. First, I think what the functional requirements you have, like PubSub or other
storage maybe.
Storage,
yes.
They are quite useful ability for the autonomous networking, but for the concepts of event service, I'm not sure, because that looks for me you are trying to do a connection of all various action regarding to events, and for me that's very risk to say. Sometimes we may have a complete list of every possible actions there.
Okay.
So for me, I would like to suggest to just do those fundamental ability like PubSub and storage,
yes,
rather than to do a layer like event service, for which I don't think that's too wide.
Okay.
To be completed.
Okay. Understand. Yes.
Arthur Hecker, one of the co-authors. So also answering partly to Turles' remark. So if you remember when we introduced first this PubSub as a need, so to say, in Prague, actually it was done in the round regarding the possible rechartering of ANIMA. So I kind of agree with what Turles said before, that in the general sense, it might go beyond the current charter. Then, however, later we have seen also that the information distribution is very much related to all this. And indeed, we can limit ourselves to the information distribution in the sense that it's a communication service, right? So we use GRASP as an example, concrete example that exists, and it's chartered and so on. But again, information distribution is not only in space, it's also in time. And that's why the storage somehow becomes necessary. There is information that must be postponed. We know it from the autonomous networking. By the way, we call it ourselves autonomous networking. And to that, belongs also the storage. We cannot just ignore it. So how we integrate it and which point and for which exact job, I do not know. And by the way, I don't think it's very important that this is just a proposal. And we can, of course, go for other proposals. But somehow we cannot ignore the storage, whether it's a distributed storage as it has been used in other groups or somehow else. But I believe it will be inconsistent and incomplete if we only provide the communication service as an autonomous service, so to say. Because otherwise, it's, we push all this complexity to the developers. And I kind of agree with what has been discussed about before, that we also need to consider developers, give them some guidance and, come up with some concrete use cases here. And not just talk about some infrastructure without any API, without any support. It will be unclear. Sorry for a long comment.
Yes, in principle, or in principle, our motivation is just like that. We are ANIMA aims to build some kind of autonomic network infrastructure for the autonomic functions of the network. So what we see here is that in addition to the direct communication model, we also see that autonomic functions may need a synchronous communication model, which we hope it can be supported by the autonomic network infrastructure in a very native way. This is just our simple motivation here. Thanks.
Please do continue to discuss in the mailing list. Thank you. So you'll be the last.
Okay, next slide. Okay, so this basically is a proposal for work that I would like to see going standards track as part of the existing charter items. So an additional milestone that kind of crosses over between ACP, ANI, and primarily GRASP. And so this goes back a little bit to the roots of what I wanted to see GRASP do. And so, we had this question, right? Why do we not use DNS-SD for service discovery? And especially in Brusky, we kind of discussed and argued that long and hard, and it's still in the Brusky draft for use outside of the ACP. And of course, we concluded on GRASP inside the ACP. And ultimately, to me, it's just, a new transport for service discovery. Now, granted, GRASP does a lot more, but it is also a transport for service discovery. But then we really didn't finish writing up all the aspects that a service discovery usually needs to entail. And I specifically wanted to avoid that people who are starting to use GRASP have to, reinvent all the bits and pieces that the IETF for service discovery has defined through DNS-SD for a decade now at least, but instead trying to come up with a, specification on how to, use exactly the same idea, but make it as efficient as possible with GRASP, right? So the specific ANI use cases are, of course, the announcement discovery of EST servers for the cert renewal in the ACP, and then, of course, the announcement discovery of Brusky servers for Bootstrap in the Brusky draft. And then something that I haven't written up yet would be a follow-up from the stable connectivity draft in terms of how to discover in the ACP a lot of the standard services in the NOC, whether it's timing, netcon servers, syslog servers, all these type of services for which, service name definitions already exist in DNS-SD that we would like to use across the ACP as well. So what is then missing in the existing GRASP definitions for DNS-SD type services, right? So right now, we haven't defined anything how GRASP could use existing IANA service names. So we would have to come up with our own service names. And if you track the mailing list for the last few years, we've always kind of, let us use this name, this name, this name. So kind of we're duplicating the effort. I think we shouldn't need to reinvent service names, right? We also have no definitions for how multiple grasp objectives could share the common attributes, like, for example, the attributes we have in DNS-SD, priority, weight, any type of other key value pairs that we have in DNS-SD, and then also how to do distance-based service selection. So, for example, registrars, if you want to have a large system, you most likely would like to pick the closest registrar, and that is roughly possible with mDiscovery, but with mFlood, which is more efficient in the face of every client being a Brewski proxy, it's not possible without, a specification. So we try to put a subset of these things into ACP and Brewski, and then basically at least the Brewski author said, well, can you just go out and, try to do this more uniquely across the different servers that we have in a separate document. And even for ACP growing larger and larger, I felt that it would be ideal to really have this in a separate draft. So that's the history. Let's try to look at what we're doing, proposing to do here. Next slide. So separate document, right? Remove all the complex service discovery details from ACP and Brewski. And then ultimately this document would meant to update Brewski ACP in a backward compatible way, meaning that what we've defined as the grasp objectives for the service discovery in Brewski and ACP would be amended with these, all optional things to basically introduce the policies that we need. And then, of course, also new services across the ACP using GRASP would be able to use those. So the only thing that we, in my opinion, need to do to make this nice backward compatible and push this off to a new draft so that we can finish and get RFCs for ACP and Brewski is really that the service names need to be mapped in a consistent fashion into the objective names. And the proposal here is that any objective name of the form serve.name is actually, a service name registered according to 6335, which is the IANA registry for service names. That's already where, service names like EST and Brewski exist, syslog and all the others. And then, of course, the registration procedures would basically say, well, we would welcome you to still register these in the GRASP registries for objectives if you're doing something new. But if you're just building a proxy from DNS-SD for MDNS into ACP, for example, then of course you don't even know what service names are there. So it would be hard to register them all in GRASP. Then the payload, what I'm proposing here in the draft is not to extend GRASP headers for anything we're doing, but instead come up with a trick on how we have a common definition of these things in all different objectives in a way that it's visible cross objectives. That's a little bit of a hack, and I'd love feedback about that. I'm not particular to how we do it, but we need to do it some way, and the proposal I'm doing should not hurt any objective that doesn't care about this stuff, and it should give a good standardized way for any objective that wants to do this. And this is meant to be extensible not only for service discovery, but for any type of future cross-objective standardized elements that we want to define. And there is one example which I think is useful outside the scope of service announcement. That's, for example, this original hop count, so that you can, for flooded messages, even if they're not for services, figure out how far away the original announcer was, right? Because in the GRASP header, you're only seeing the loop count as it arrives. You don't know how many hops it has traveled, how much it was decremented. So here we have a new element that says here was the original hop count that the sender set when he sent it. So now I see in my GRASP header it's been reduced 15 hops. So this announcer is 15 hops away from me, and another announcer is 30 hops away from me. I'm going to maybe, for whatever I want to do, pick the closest one, or maybe the furthest one. Next slide. All right, so DNS SD in half a slide. So in DNS SD, basically there is an intriguing encoding of services data into DNS resource records. And intriguing meaning also to imply it's somewhat convoluted, but that's required by the way DNS was built. I think 2 decades before DNS SD came along, the service record was there, but then it did a bunch of other things, and it also did try to focus on a use case, which I wonder how important it's going to be for autonomous networks. So let me quickly show on the beginning, you see something like you have a service, and that's basically pointing to a bunch of service instances. And the service instances are names that are primarily meant for human consumption and selection, right? So, for example, you're looking up a printer service, you're getting back, and that's called browsing, a list of service instance names that are nicely human readable names like my printer, your printer, and their printer. And obviously, by looking at, your user interface, you know which printer you're selecting. So now, if I'm basically not autonomic service agents, I wonder how important this form of selection of one out of multiple service instances is going to be, as opposed to a selection based on more formal parameters of a service instance. And these more formal aspects of a service instance are embodied in DNS-SD in two parts. For once, there is the serve record, which has the priority and weight, which are simple numerical things to select a service instance. And then there are optional service-specific parameters. And, if you're trying to use a service, maybe you want to look up the service parameters. Like, I don't care if it's your or my printer, right? As long as I can see it, hopefully I can pick up the print. But I'd love a color printer. I'd love a printer with A3, and all those things would be in these key value pairs, right? So for that reason, and looking in, how we encode the things in GRASP, the idea was, well, let's make service instance names optional, and it's basically up to the service to figure out if they actually want to introduce service instance names. In DNS-SD, it's kind of mandatory from the history and also how DNS-SD works. Then also the next step, you see that in the serve record, there is also the host name. So the service resolution from the service name over the service instance name goes into a host name, and only that host name goes to the actual locators of the transport ports on which you can consume the service. And these host names, well, ACP, we don't have, a mandate to support DNS or host names at all. So host names in our case would also be something that by default we wouldn't use. I also defined a way to introduce host name resolution through GRASP as part of this. I have it in the last slide, but I would also think in general it's optional. So if you think of it, GRASP service resolution, in many cases, because we're using it from automated entities, ASAs in the network, could be a lot simpler than, in many cases, DNS-SD that was meant for human consumption. Next slide. So here is the wonderful CBOR CDDL formatting of a service record, which in GRASP, we would have as part of the objective value. So this is basically the element you're inserting, and pretty much everything is optional there. So first of all, private parameters, which is basically whenever we want to extend something and it's not standardized anymore. Then we've basically got the message type, and that's basically where we're saying, okay, we're basically going to describe a service, or we're requesting a description of the service, or we want to enumerate it, or request enumeration. Those are pretty much the four simple operations that I think we're going to get away with. Then the service, right? That's a service name. It's duplicated here. It would also be in the objective name. It needs to be in the objective name because that's where, GRASP needs to have something that you're announcing or that you're looking for in an M-discovery when you're looking for a service, right? So it's duplicated in here primarily for the point when you have an announcement of potentially multiple services. Then the instance name, right? So my kitchen printer, optional. Then I also added the domain. So functionally, service discovery about across GRASP, one simple way to understand it, it's like a humongous large network version of MDNS, like it's flooded in the network. So by default, the domain would be .local, and that's kind of the GRASP instance you're using, like the ACP, but it could be other names as well. In that case, we need to add more functionality on how to do that. Priority weight, as in DNS-SD, key value pairs, set of key value pairs exactly like DNS-SD. Then I added a new parameter called range, which is basically weighting the service selection between priority and weight versus the distance, right? So whether you're more interested in distance-based service selection or more priority weight, I'm not going to control what the algorithm is, read up on the slide, so hopefully a flexible way to allow you to define in your service definition whether it should be priority weight and or distance-based selection. And then C locators. So GRASP has locators, and the C locators are simply extending locators with one other element, which is a bloody small string telling you in which context this locator lives. Because in the classical ANI environment, we already have two contexts. One is the ACP that we usually assume, but for many ASAs, it would be very valuable to also have locators across the data plane, because the data plane may have higher performance, or you may, for other reasons in the ASA, have knowledge about the data plane locators of a particular service instance, not only the ACP. So that's basically now context locators, so that both are possible. And yeah, that's basically the service structure, and that allows us to express everything that we can express. Well, they're small, you know, not that often used details in DNS-SD that we haven't covered here, but let's say 90% of what DNS-SD can do, we can express here. Also in a bidirectional way, you could build a gateway, you know, converting one into the other. Next slide. So these are the message exchanges, right? The most simple one is the GRASP mFlood, right? That's an unsolicited announcement of objectives, service instances. Message type is describe, right? You're describing a service. If you're doing a unicast, the other flooding option is mDiscover. You find an objective, that's a describe request. It defines that most of the attributes in the describe request are invalid. The only thing of interest are the service, maybe service instance name that you're looking for. And it's actually a very interesting paradigm for service discovery, because it does, the discovery stops at the first instances found, right? So you can't have all the policies in terms of priority weight in this discovery in GRASP, but in a large network, it's a lot more efficient because you're not flooding something, right? If you're basically having a lot of distributed service instances and the policy is always don't bother the whole bloody network with the fact that you are there and offering a service, which is really meant for your vicinity, mDiscovery very efficiently supports that, right? So in that respect, of course, GRASP and the schemes that we have is a lot better than simple, let's say, MDNS-based flooding alone. That would be mDiscovery. Then, of course, the same type of things can be done equally through unicast negotiations when you're just talking about service negotiation, discovery announcement, between instances that have already found themselves, like, oh, I know here is a big, you know, gateway for all type of service to the NOC. And then enumerate request, they would basically not return the locators, but would only, as in DNS-SD, only return the service instance name, and then you do a second lookup from a service instance name you're interested in into its parameters, including locators. Right? And the backward compatibility is simply by the fact that the way that the service element is defined means that if you don't have the service element, but you're just having what is currently in the ACP draft and what I would also like to see in the Brewski draft, which is just, you know, it's a service serve.brewski, serve.est, no other parameters. It simply means that is a describe. The locator to use is from the GRASP header, and you're done with it, right? So that's the full backward compatibility. As soon as you add the service element to the objective value, you're basically supposed to look into all these, you know, elements, priority weight, and so on. So that's kind of the gist of the proposal. Next slide. Yeah, so here's the encoding on how to put the service element in a way into thousands of different objectives in a way that it can be easily detected, and if you don't care about the stuff, you don't need to have to do it, and we don't need to come up with new GRASP header extensions for, quote, IANA registered common objective value elements, which this effectively is. So basically what you're doing is the objective value needs to be a map. A map is what is easily extensible, which means it's a set of key value pairs. And we're simply going to define one key, which is going to be, you know, a magic string at RFC something something, which would be the number of this thing. And then inside of that, we again have a map, which is a set of key value strings. And each of the keys would have to be an IANA registered reused service element. And the two ones that we're defining here in this draft is the sender loop count, which is basically what, you know, the sender announces in the mFlood. And then the other one is the service element, which I was just describing. So those are the two. And then if in the future somebody comes and says, hey, across different grasp objectives, there is this one function, this one, data structure that I want to reuse, well, get yourself an IANA allocation, put it in there. So that's basically the simple encoding that gets us rid of having to extend grasp headers with some standard payload things, which we didn't do. And I think this should hopefully work equally well. Next slide. Yeah, so this was basically just the last optional thing about name.something, objective to basically look up host names, because DNS SD has this, and if we want it, we can do it. Think about how useful that is. I think it is quite useful if I look at how wonderfully well, networks are usually managed, like, all the equipment, routers, switches, all the stuff has host names. But guess what? The likelihood is that they're consistently, correctly, and up-to-date registered in DNS. They're much less well registered in DNS than, let's say, host names of poor users, right? Because poor users can't even get a bloody IP address before they go to the administrator and say, I want to have a host with the following name, and then he gets an IP address after somebody has basically approved that name. Not so for network equipment, right? That's basically a totally different domain. So I think for operational, we're an ops group, I think using also grasp in the ACP to do quick infrastructure component host name lookup is a nice workaround. All right, I think that was the slide deck. Questions, comments? Yeah, so I'll also try to give a variant of this presentation on Wednesday. The DNS SD working group asked me to do that, but I probably need to focus less on these wonderful details of the encoding, but rather more on what the heck is ANIMA and why is it doing something new, right? So it will be different. I'll have to put these slides together first.
Interest in the room?
This is the time when you all jump up to the mic.
Okay, let's take the discussion into the mailing list. Next. I believe that's all the presentation for today. So thanks for all those presenters to keep the perfect timing. So we have 2 minutes left. So we have done all those presentations, and we are actually still continue to calling new work item, new proposals. But before you submit anything new, please check the current agenda. Although it's extendable, but we would like to give any priority to the current agenda relevant work items. So thank you all. See you all in London. Yeah, thank you. Anyway, I haven't signed the blue sheet. Please come. I'll take care of the blue sheet.